There is also an alternate step-by-step method by step-by-step by Ipsen 1916. The pi theorem method just explained and illustrated is often called the repeating variable method of dimensional analysis. Select the repeating variable and one more and you get a pi group. The writer likes it. This method is straightforward and systematically reveals all the desired pi group. However, there are drawbacks that all pi groups contain the same repeating variables and may lack variety of effectiveness, and for pi group we have to condition all pi groups contain the same repeating variable. Variables, and one must check that the selected repeating variables do not form a pi group among themselves. One must check that the selected repeating variable do not form a pi groups among themselves. These two conditions are for pi theorem, and there is also a Ipsen suggests an entirely different procedure, a step-by-step method that obtains all the pi groups at once without any counting or checking. One simply successfully eliminates each dimension in desired function by division or multiplication. Let us illustrate the same classical derived function related to consider the equation f equals to rho v and L and mu. We have three dimension f, which the dimension of is mlt minus 2. Rho, the dimension of rho is ml minus 3. The dimension of v lt inverse, and the dimension of L and the dimension of mu is the ml minus t minus 1. There are three dimensions, ml and t. So let me write in the next page. 3 dimension ml t, f was mlt minus 2, v lt minus 1, L rho was ml minus 3, and mu is ml minus 1 minus t minus 1. Eliminate them successfully by division or multiplication by a variable. Start with mass. Pick a variable that contains mass and divide it into all the other variables with mass dimension. So for example, for row, we can write, for example, we have f, a function of lv row and mu, lv row and mu. So we divide into row, we have this relation, a function of L, V, and row eliminate. In this case, the dimensions becomes L4 T minus 2 L on L VL T minus 1 and mu on row L2 T minus 1. We did not divide into L or V which do not contain M. So because L and V do not contain M, so we don't divide by row for L and M. Equation at first looks straight, but it contains 5 distinct variables and same information. We see that row is no longer important because no other variables contain M, thus discard row, and now there are only 4 variables. In the next step, we can eliminate row, so we have this relation, a function of L, V, and mu on row. Dividing on V, for example, in the next step, we have this relation, row V2, a function of L, V, and on row V. The next dimensions are L2, L, LT minus 1, and L. We now see that V is no longer relevant since only V contains time. Finally, eliminate L through the division by, we don't also divide to L to the V because it don't contains M. Again, in the next step, we have this relation. L and on row V. So the last step is to divide by L, and we can obtain divide. We have the dimension L2, L, and here also we have L. The dimension is also L. By dividing to the no L by itself is no longer relevant, and so discarded. Also, the result is given to F row V2. To obtain a non-dimensional, we should divide with L2, and in the function we eliminating L, we should divide in with L. So the final relation is F on row V to L2 F M on row VL. This is the final in Ipsen step-by-step method final relation. We find the force coefficient is a function of solely of the Reynolds number. We did no counting and did not find J. We just successfully eliminate each primary dimension by division with the appropriate variable in each step. And another example, for example, consider the beam deflection problem that give us the function for deflection as a function of P, L, I, and E. We have the dimensions for delta is L, dimension for P is ML T minus 2, dimension for L is L, and inertia L4. Energy is L minus 2, T minus 2, L minus 1, T minus 2. There are only one parameters that contain M. For example, if we want to eliminate M from this relation, the next relation is equals to, we don't divide delta because it does not contain M. P on E. Also L and I does not contain mass, M, length, mass, excuse me. In this case we eliminate E. We have the dimension for next step as L, L2, again L and L4. The next step is we have this relation L and I. The dimension are L, L2, L and L4. We see that we may discard E as no longer irrelevant and the dimension T has vanished along with M. We need only eliminate L by dividing by, say, powers of L itself. So at the right hand side we can eliminate the dimension of delta P on. To eliminate the dimension of P on E, we should divide to L2, PE on L2, and L on L, which eliminate, and I on L4. In this step we eliminate L. The next function reduces to I on L4. As when approach is assigned successful, the fact that M and T vanished in the same division improves that there are only two repeating variables this time, not three that would be inferred by presence of M, L, and T. So in this case we have two pi groups, one pi 1 for example and pi 2 with using the Ipsen approach. The next section is about, there are also examples related to the Ipsen step-by-step method. The next step is non-dimensionalization of the basic equations.